Hello everyone, my name is Nathan Owen.
I'm Kendall.
I'm James Monaghan.
Today we're going to be talking to you about the impact of calderas in civilization today.
So, we're going to be talking about what calderas actually are. We're going to talk about Moku Uwewo caldera and the Yellowstone caldera, as well as conclusions and further questions. So, according to the National Geographic Society, a caldera is a depression created after a volcano releases the majority of its contents of its magma chamber in an explosive eruption. Without structural support below, the top collapses on a volcano, causing a bowl-shaped caldera. So basically, I'm going to draw a little diagram for you to understand exactly what happens. If you can understand my drawings, here is a volcano, here's a magma chamber below, and basically the pressure building up below of just magma rising in general and plate tectonics, earthquakes, what have you, will cause cracks on the sides of the volcano, and after a while, just build up pressure and whatnot, the magma will actually spill out the sides and begin to run down the sides of the volcano, and the top will actually collapse down and create like a bowl shape, and that will fill with groundwater, rain, snow, what have you, and cause huge lakes, like shown in this picture right here. This is Helena Lake in the Newberry caldera in Oregon. Another example of there are three types of calderas. There's crater lake calderas, shield volcano calderas, and resurgent calderas. And this right here is Paulina Lake and Newberry caldera. Also, there is Crater Lake, which is also in Oregon. Crater Lake is a caldera that's about 10 kilometers wide, and the crater collapsed and filled with water, rain, and snow created in the lake. Subsequent eruptions of Mount Mazama built up the Wizard Island, a volcanic cone that formed an island on the western end of the lake. Moku Uwewo is a shield volcano caldera in Hawaii, which we're going to talk about later in our presentation. And the other type, an example, are resurgent ones. They're the largest volcanic structures on Earth, and they range from 15 to 100 kilometers in diameter. They're not specific to one volcano, but rather a large system of magma chambers. A great example of that is the Yellowstone caldera, which we will also talk about later in our presentation. So we're going to move on to the one Hawaii.
So thank you for that great introduction, James, of calderas in general and their different impacts and different types on civilization today. So today I'll be talking about Moku Uwewo caldera. And it's located at the summit of Mauna, which is actually a massive shield volcano that helped form the big Hawaiian island, or the main one. In fact, actually, Mauna helped form over 85% of the chain of Hawaiian Islands itself. Although, that since it's a shield volcano, and James had talked about, it's one of the major types of calderas, and shield volcanoes actually do not form from an explosive manner. Rather, shield volcanoes actually form in a gradual releasement of lava, and that it forms a Great Depression and thus creates a caldera. And actually Hawaii is made up of 5 shield volcanoes. They're all entirely shield volcanoes that helped create Hawaii over hundreds of thousands, millions of years. And as I mentioned, they form in gradual stages, and actually Moku Uwewo caldera is approximately 6 square miles in total size, and is actually 600 feet deep at its deepest portion. As you can see on the right, picture on the right, there are 3 different sections of calderas. They're not craters. People they mix up craters with calderas because craters are actually formed from the outward explosion of volcanoes, rather than where calderas are formed from the the collapse of volcanoes within them. So talking more about Mauna itself, again, they had formed when the Pacific tectonic plate moved over the Hawaiian hotspot. This is what actually formed Hawaii millions, hundreds of thousands of years ago. We talked about in class how what all the different structures and natural disasters that tectonic plates can cause. And again, Mauna Loa is the largest active volcano on the planet, and it is expected to erupt again sometime. Its last eruption was in 1984. It was very common and very consistent in the early to mid 20th century, with a total of about 33 eruptions. And the last one was in 1984, but I'll talk about that more later. And Mauna Loa actually literally means in Hawaiian, long mountain. And that because, as you can see on the picture on the right, this is the main Hawaiian island. Mauna Loa actually takes up, I'd say, roughly 60–70% of the island itself. And they don't have shown in this picture, but it also helps create the chain of islands as well. And lastly, I'll talk about some of the impact and steps of solution for the Mokuʻiʻiʻu caldera and the Mauna Loa itself. As I mentioned, it is still an active volcano, actually the largest in the world at the moment because of its sheer mass. It's actually, from its summit of Mount Loma all the way down to its base, it's about 55,000 feet. So it's been a long time building upon itself. And again, the last eruption was in 1984. However, it rarely caused any casualties, but it does create a negative economic impact due to the fact that the lava is destroying structures and causing damage. And then also they have their national park volcanoes, which for Hawaii, which is a major tourist attraction, that always has to be shut down if any volcano erupts. And lastly, eventually, the only solution really is time. As we know, these tectonic plates move over hundreds of thousands to millions of years. Was an inch a year or something like that. So it takes a very long time, and eventually the present plate will move over from Hawaii, and it will not be a hot spot anymore. And talking about this, we will lead into more and more present issue at the moment, and Kendall will talk about that.
All right, so I'm going to be talking about the Yellowstone supervolcano. It is a caldera, and it is arguably one of the more recognizable calderas that we have, especially here in the United States. We have a lot of visitors that come visit the Yellowstone National Park each year to go see the geysers, and just the park in general is really beautiful. But the Yellowstone caldera was actually formed in a series of 3 major eruptions. The first one was 2.1 million years ago. It was the Huckleberry Ridge Tuff, which is this one over here. Now that one formed a volcano that was, or a caldera that was 60 miles across. The second one was the Mesa Falls ash bed, and that one happened 1.3 million years ago. It formed the Henry Park caldera. And the most recent one that actually formed the Yellowstone caldera itself was 640,000 years ago. It was the Lava Creek Tuff. So you can see just how far the ash from that explosion spread. There's still ash that is present in Iowa, Louisiana, and California. Even though that eruption happened 640,000 years ago, we're still able to see the effects of it. Now, the likelihood that Yellowstone would erupt in such a way that it did these past 3 times in our lifetime is slim to none. But that does not mean that there's no dangers present with Yellowstone. There is a lot of activity that's happening under the surface that causes mostly a lot of earthquakes. There are 1,000 to 3,000 earthquakes that happen every year in the Yellowstone region. Most of those are undetectable, but some of them have been deadly. The worst one in recent history was one in 1959. This ended up causing $11 billion, or $11 million in damage in 1959 dollars, but at the time the fact sheet I read by the United States Geological Survey was written in 2005. They calculated it to be in about $70 million. So in 2018 dollars, that would be even more. I didn't end up calculating that, but that would be a lot of money that had to be going into repairing for that earthquake. Now, I didn't write on this slide, but also another threat that the Yellowstone caldera has are all the geysers that happen. Now, like James said earlier, there's a lot of magma that is flowing underneath Yellowstone, and that magma heats up all of the water underneath it. And with the rising heat and the building up of pressure, occasionally water will just shoot up out of the ground, dispersing rocks. And this water is way above boiling temperature. It can get up to 460 degrees Fahrenheit. So anybody who's in that area, when a geyser would shoot up, that could end in some deadly consequences. I could not find any injuries, thankfully. But again, if there wasn't anything or any monitoring that's going on, which I'm going to talk about in a minute or so, if there wasn't any monitoring of what's happening under the surface, there could be a lot of damage that those geysers could cause. Now, a recurring theme with volcanoes is there's not really much you can do to prevent them, because we're just kind of, we build around volcanoes. We can't really try and prevent them, but one thing we can do is help keep the public updated with what's going on with the volcanoes. In 2001, the USGS formed the Yellowstone Volcano Observatory. They're working with other observatories and the Wyoming, I believe the University of Wyoming, to have monitoring stations in different areas, so they're able to tell what is happening with the area in Yellowstone National Park. They have a series of different warnings, like fly zone, when there's no-fly warnings, because something could happen with the volcanoes. And that is, I believe they have 24/7, someone there 24/7, checking the monitors and updating the website. So if anybody was looking at visiting Yellowstone National Park, or for anybody who lives in that area, they can just go on the Yellowstone Volcano Observatory's website and they'll be able to see what's going on with the volcano, if they need to evacuate, or if they should maybe hold off on their vacation, or something like that.
All right, guys, and this is our presentation. Thank you very much for your time and attention. Are there any questions?